Unit 1, Lesson 6, Multiplying and Dividing Rational Expressions. So to multiply fractions together, you guys know that you just take the numerators, multiply them together to get your new numerator, and multiply the two denominators together to get your new denominator. Multiplying rational expressions is the same. You just multiply straight across. The only thing that's different about rational expressions is that sometimes there's going to be an opportunity to factor. So if you're asked to multiply together two rational expressions and you can factor them first, do it. And as per our last lesson, you must also state restrictions at the end. Because it's a rational expression and you have a denominator, which values can x not be, or which values of x turn the denominator into 0. Okay, so let's get into some examples. 9x squared divided by x times 12x divided by 3x to the power of 4. Now, there's obviously no factoring that needs to happen because there's only one term in both the numerator and the denominator. So let's just go ahead and multiply straight across. So 9x squared times 12x, multiply the number parts first, so 9 times 12 is 108, multiply the variable parts, so x squared times x to the power of 1, you're going to use your product rule, it's x cubed. Same with the denominator. Numbers first, so 1 times 3 is 3, x to the power of 1 times x to the power of 4. Product rule says that that's x to the power of 5. Okay, now let's reduce that. So 108 divided by 3 is 36. X to the power of 3 divided by x to the power of 5. You're going to use your quotient rule. So x cubed divided by x to the power of 5 is equal to x to the negative 2, which really turns into 1 over x squared. So we have x squared. Okay, and now we need to state our restriction. So let's set our denominator equal to 0. Okay, and solve for x. So take the square root of both sides. We get x equals 0 as our first and only restriction. So your final answer would be simplified to 36 over x squared with the restriction that x cannot equal 0, because if x was 0, that would make our denominator 0. Okay, let's multiply this together. So we'll multiply our numerators first. So 2a plus 6 times 3 is 3 times 2a plus 6. Okay, and we're not going to distribute the 3 into our brackets, because then we're going to go kind of one step backwards and we're going to have that much more to do when we have to go factor them. Okay, and in our denominator we have 7 times a squared minus 9, which is a difference of squares. So let's go ahead and factor this now. So 2a plus 6. Okay, common factoring is the only thing we can do here. Factor out a 2 and we're left with a plus 3. And in the denominator we can do difference of squares, so we get a minus 3 and a plus 3. Okay, and then obviously we have some common factors here that we can cancel out, a plus 3 and a plus 3. So in the numerator we're left with 3 times 2, which is 6, and in our denominator we have 7 times a minus 3. Okay, so that's our simplified version of the rational expression. Let's come up with our restrictions. So for our restrictions, we get our restrictions from the factored version. Okay, not necessarily the final answer, because the final answer we canceled some things out. So set each of your factors to 0. So a minus 3 equals 0 and a plus 3 equals 0. A cannot be 3 and a cannot be negative 3. So our two restrictions are a cannot be positive 3 or negative 3. So that's your final answer. Simplified version of the rational expression and the restriction. Okay, so part C is very involved. We have to factor both the numerators and denominators in each term here. So let's go ahead and factor the numerator here. So we're going to use decomposition. We need two numbers that multiply together to get the product of a and c, so 4, and add together to get 5. So the matching numbers are 1 and 4. And then in the denominator there, we need two numbers that multiply together to get negative 20 and add together to get negative 8. So it's going to be negative 10 and 2 times, let's factor the numerator of the second term here. So we need two numbers that multiply together to get 30 and add together to get negative 11. So it's negative 5 and negative 6. And then in our denominator, we need two numbers that multiply together to get 6 and add together to get 7. So it'll be 1 and 6. So you can see why you have to be really good at factoring. Okay, let's go ahead and factor by grouping. So you're going to notice that our two brackets didn't turn out to be the same. Okay, and we know from practice that this is an issue. So what we can do as a quick fix is we can try switching the order of our b terms. So instead of plugging it in with the first magic number, the 1 first and then the 4, let's do 4xy plus 1xy and see if that changes it. Okay, so let's try this again. And look at that, it worked out. So sometimes when it doesn't work out, just switch those b terms, the order of them. Okay, and in the denominator, we can factor out a 2x. Okay, now let's factor the other side. Oh, and just a quick issue I see here. I did not replace my b value with the two magic numbers, so just quickly fix that on your own page. Okay, now let's common factor that. Okay, now let's clean this up a little bit here. So let's put our two common factors together in a set of brackets. Okay, let's cancel out anything that we can. So we can cancel out our 2x plus y. Now let's go ahead and write these all together, because this numerator times this numerator is just this. Okay, we can see if there's anything else that we can cancel out now, right? So we have a 2x minus 5y on both our numerator and our denominator, and we have an x plus 2y. So we can cancel out those guys as well. So our simplified version is just x minus 3y over 3x plus y. Okay, now to figure out our restrictions, let's go to the factored version of this. That's going to be right here. And let's take each of our factors in our denominator, set them equal to 0 to figure out what our factors should be. So our restrictions are x cannot be negative 1/2 y, 5 over 2y, negative 2y, or negative 1 over 3y. So that's our simplified version with our restriction. Okay, our final question is a division question. So remember, when we're dividing fractions, we want to turn it into a multiplication question by essentially multiplying by the reciprocal. So we're going to multiply by the reciprocal, so we're going to flip that second fraction. Okay, let's go ahead and factor each of the numerators and denominators. So we need two numbers that multiply together to get 2 and add together to get 3. So it's going to be 1 and 2, and because a is 1, those magic numbers become our factors. So the numerator factored is just x plus 1 and x plus 2. The denominator, we can common factor out an x squared. In the numerator, we can factor out an x. And in our denominator, we need two numbers that multiply together to get negative 2 and add together to get negative 1. So that's 1 and negative 2, and those become our factors right away because a is equal to 1. Okay, now let's just simplify even further. So in our denominator, we have a difference of squares. Okay, and in the numerator, let's factor what's inside the brackets. So we need two magic numbers that multiply together to get negative 10 and add together to get negative 9. So the magic numbers are 1 and negative 10. So we're going to replace our b value with those magic numbers. Okay, so in our first fraction, we can simplify this, right? We can cancel those two out. Okay, now let's keep going. Let's factor by grouping. Okay, and now let's just clean up that last fraction there. This guy's already done. Okay, and we can see we have some simplifications there. And now let's multiply the numerators together. We get x plus 1 times x times 5x plus 1. And now let's multiply denominators together. So we get x squared times x minus 2 times x plus 1. So we have a little bit more canceling out that can happen. So our 2x plus 1s we can cancel out. We can cancel out this x, and this guy becomes just x. So our final simplified answer is 5x plus 1 over x times x minus 2. Okay, let's state our restrictions. So let's go back to when our denominators were in factor form. So before we cancel anything out, so that's this right here. So our first restriction is setting this guy to 0. Okay, so our first restriction is at x equals 0, second is at x equals negative 2, third is at x equals positive 2, and our last one is at x equals negative 1. Now, there's still a few more restrictions. So because at the very beginning of the question, this polynomial was our denominator, and then when we multiply by the reciprocal, it turned into the numerator. It still counts as a restriction because originally it was our denominator, right? So if that polynomial ever equaled 0, it would also count as a restriction. So let's find the factored version of this polynomial, okay? And that would be right here. Okay, so we have to add in a new restriction. Okay, x we've already got covered right here. X minus 2 we've already got covered here. But we also need to add a restriction for 5x plus 1. So our other restriction is at negative 1/5. So therefore, our final answer is simplified there, and our restrictions are x cannot equal 0, negative 2, 2, negative 1, and negative 1/5. Okay, so just know that to simplify rational expressions, you must factor first, then cancel out any common factors, and then you want to find your restrictions by setting each factor to 0 and figuring out what x cannot be. Just keep in mind this one trick. If ever it's a division question, there's an extra restriction, and that comes from the original denominator in the question.